All right, guys, let's get going. We've been approximating area under curves using rectangles and having a lot of fun, right? But today we want to use trapezoids. Now, you might remember the trapezoid like this, right? They're always drawn where the parallel sides were horizontal, right? Doesn't that look familiar to you, trapezoid? But if I take this, what made it a trapezoid? Do you remember? How did you know it was a trapezoid? Yeah, it had a pair of opposite sides that were parallel. Okay, but you do agree it's still going to be a trapezoid if I turn it and the parallel sides are vertical, right? Because that's how we're going to use them today. So the area of a trapezoid, of one trapezoid, is equal to 1/2 the height. Now the height is the distance between the bases, the parallel sides, times the sum of the bases. Does that look familiar? You can tell me if it doesn't. No? I always get that from kids, the whole geometry thing. I don't know. Well, let me show you where that comes from just for 1 second. Do you agree we can take a trapezoid and we can just we can look at it as being the sum of these two triangles? What's the area of a triangle? 1/2 base times height. So it's 1/2. We could use this side as base 1, and the height is still going to be the same, right? Because it's this distance here. And then the other one would have an area of 1/2 base 2 times the height. And you factor out the 1/2 h. So that's the area of a single trapezoid, right there. What's your good question? Oh, then forget it. It's not a good question. No. We still have a lot of people that need to take it. By the way, oh yeah, so the little tiny do now I have for you today while I quickly check your homework is to write down the area of these trapezoids, and the only thing that's different is how I've labeled the sides. Okay, instead of calling them B1 and B2, they're Y1 and Y2 because they're going to be the Y coordinates. We have them that way. So do that for a second. I'm going to quickly check homework. I'm expecting good things. I don't know. Okay, so what is the area of this first trapezoid going to be? 1/2 each. Y1 plus Y2. No problem, right? Oh, why did I do that? What is that? B minus A over N? What? Yes, Ryan. Yeah, it's the same as the width for our rectangles, right? We're going to get it the same way. So the height of our trapezoid is simply going to be, we're going to get it the same way as we do the width of our rectangles, B minus A over N. So what is the area equal over here? 1/2 B minus A over N, Y1 plus Y2. And if you want to multiply the 1/2 by the B minus A over N, you could, right? You could write it as B minus A over 2N. It's very warm here today. I'm dozing off a little bit. Okay, do you think we're just going to find the area of one trapezoid? Don't worry, kids. So don't look at that yet. We're going to do that after. Think about what we're going to use these for. We're going to use these to approximate the area under some graph from A to B. Now, I didn't draw the actual graph. I'm just drawing in the trapezoids. Ready, guys? All right, now, if the heights of each one of these trapezoids is the same, what can we if we want to get the sum of all these areas, what can we factor out? What will they all have in common? The half and the height, right? The 1/2 height. All right, so we're going to write down our trapezoidal approximation. The cool kids call it TAM, trapezoidal approximation method. So we're going to factor out the 1/2 and the height, because it's going to be the same for each one of these trapezoids. So why keep writing it? So all we need is to multiply that for each trapezoid. What are we going to have to find? What do we do with the bases? Yeah. Yeah, you need the sum of the bases for each trapezoid, which are going to be the y coordinates. They're all like a little right in there. So for the first trapezoid, what are the bases going to be? What am I going to write down? Y at A, plus 1 at 1. Okay, that's the sum of the bases for the first trapezoid. And you could put it in parentheses, but you don't need them because you're adding, you know, it's not like you have to distribute anything. All right, now we got to add that to the sum of the bases for the second trapezoid. So for the second trapezoid, well, now we're moving on to this one. It's y1 plus y2. We need the sum of the bases. So y1 plus y2. I'm not even going to try to fit it on one line. Now we got to get the sum of the bases for the third trapezoid. What do I write down? Plus y2 plus y3. Nice. Moving on to the next trapezoid, what do I write down for the sum of the bases? Plus y3 plus y4. Good. Moving on. I'm glad I put so many of these on here. To the next trapezoid, y4 plus y5. Moving. Plus y5 plus y6. I get that. And then the last one, y sub 6 plus y at b. Whew! Wow. I had to close the parentheses because it was 1/2 the height times the sum of the bases for each. Whoa, that's a lot. You notice anything? There's 2 of all the internal bases. Why would there be 2 y1s and 2 y2s in this? Yes. Each one of these internal bases is a base for the trapezoid on the left and for the trapezoid on the right. That's why you see it twice. So let's clean this up a little bit. So you have 1/2 the height. I only have one of the first base. So y, we're going to leave that. But now I'm going to be able to clean this up. I'm going to write plus 2 times. I'm going to write that in red because it's important. And that's what we do when it's important. 1. All right. What goes in the parentheses? Oops. Whoa. Oh. Okay, so plus 2 times, what do I write in here? y1 plus y2 what am I going to do? What happened? I put up the brakes on. Close. We're not going to keep doubling anymore, right? Close. I'm bugging out. I just, you don't want to keep doubling forever, right? You only want to double those internal bases. Oh, great. And I'm hooked up. Just a minute. Yeah. Okay, now we're back. So, guys, this is how we're going to get the trapezoidal approximation for the area under a graph. What? Yeah. So this is, no, well, you're just going to remember the whole pattern. Oh, I have that correct. This is what you have here. So I just wanted you to see, if I just gave you this formula, when you would think, oh, no. But think about it. You know, you just keep the first y. You're going to use all the y coordinates of those important, the endpoints of the subintervals. But you got to double all the ones in between. And the h, just remember, is b minus a over n, just like it was for the width of a rectangle. All right, let's have some fun with this, shall we? Let's do it. Nope, not yet. There we go. This is awesome. Look what we're going to do. We are going to approximate the area under the graph y equals 100 minus x squared from x equals -8 to x equals 10 using, it's covered up, how many do I have under there? 6 rectangles. See, kids at home? 6. 6 rectangles. Okay. So the first, 6 trapezoids, sorry. All right, just like with the rectangles, the first thing you're going to have to do is figure out, well, the rectangles, what did I tell you to figure out first? The width, right? So for the trapezoids, what are you going to have to figure out first? Yeah, we call it the height, but you're right. Same thing. So can you guys figure out if we're going from -8 to 10 and we want to fit 6 trapezoids in there, what the height of each one's going to be? Well, that was fast, right? Because you take B minus A over N, and you're right, 18 over 6 is 3. Before you do anything else, you want to mark off the important x values, the ones you're going to be plugging in to get your bases. So you don't just want to mark up every single x value. That's going to mess you up, believe me. So what's the first x value I need to mark? -8. Now this goes -10 to, so right here, it's -8. Now we said the height's 3, right? So what should be the next x value that I'm going to have to use? Well, 10 we're going to need too, so I could put that there. That's what I'm going to add. I'm definitely going to need that one. But if I'm here at -8, the first subinterval, it's going to go from -8 to what? -5. So that's what you want to mark. What would the next x value be? -2. Keep going. Keep going. 1. Keep going. Try missing funny. And then 1, 2, 7. There's a little disruption. Does everyone understand where these numbers are coming from? If you don't get that, you're going to be lost. I'm telling you. You start at your A value and just keep adding the height. That's going to be where the bases are going to be. Yes, yes. We broke it up. Now, so it's going to be important to know the y values just at these x values. Oh, look how nice. She gave us a table. Well, let's put that in here. So we want to make sure we know the y's at each of these values. -8, -5, -2, 1, 4, 7, and 10. Those are going to be our bases, those y coordinates. So let's get them. We don't need a calculator for this because this is nice and easy. What's 100 minus -8 squared? 36. How about 100 minus -5 squared? 100 minus -2 squared? 100 minus 1 squared? 100 minus 4 squared? 80 something. 4. 100 minus 7 squared? And 100 minus 10 squared? 0. Alrighty. Now, I don't need the graph to do the trapezoidal method. You need it for inscribed and circumscribed rectangles, but for this you don't. But I still want to do it anyway. All right, because I want you to see it. I want to see this parabola. Actually, I'm going to add in the y-intercept. That's easy enough. That's just going to be 100. So let's just plot these points. And you just we'll get a rough idea of the graph. Did I just move my graph over? All right, no, that's good. Oh, this is moved over. I don't know what that is. No, all these things that I just wrote, something got moved. Oh, I know. Wait a minute. I got to get out of this. I got to select this whole thing. Yeah. All right. That's all right. No, I don't want it to do that anymore. Okay. So we're just going to plot these points. So we got 100, 10 was 0, 7, 51, going up to 51. 4, I'm going up to 84. 7, I'm going, oh wait, I already did 7, I'm going this way. 1, I'm plotting points. Going up to 99. I started down here and I'm going this way toward me. So, oh, this is 100, 0, 100. Let's see. -2, 96. no, I keep going the wrong way. Negative 575. Okay. And negative 836. No, I'm over here. Okay. So I just want to get like a sense of connect the dots. And again, you don't really need to see the graph, but I just want to draw in the bases. You know, with the trapezoids, they're really fun to draw because all you do for each of these key x values, you just draw a vertical line up to the graph. I'll show you how you make the tops in a second. But wow, it's a really lumpy looking parabola. I didn't realize how bad that was. Sorry. It's pretty bad. But now, so that, you know, so you can see the trapezoids, right? But we have to get the top. You just, this as straight of a line you can make, you know, just go. Oops. Sorry, I'm a little worse. Oops. The last trapezoid is a triangle because one of the bases is 0, but that's fine. It still works. Be cool if I could shade them all in. You'd see them better. Fun. All right. Do you think when we get this approximation, it's going to be less than the real area or greater than the real area? A little less, because we're missing just, but it's going to be pretty darn good, right? Much better fit than a rectangle. You know, like the rectangle just go across and you miss like a whole chunk of area. Or too much. All right, let's get our trapezoidal approximation. Let's do this. Oh, I need that table. Do you remember what was on the outside? 1/2 the height. What was the height in this case? 3. Okay. And then we need parentheses. Now, what's going to go inside? What are my heights? What happens to the internal ones? Think about what I'm going to put down now. What's the first base? No, no. Now, this is my... Wait a minute. Oh, this is my recording. Wait, all right. Shout out to Mike. Shout out. Mike, start paying attention right now. Oh, look, we're recording you guys saying I was talking bad about you. How wrong is that? Good luck. All right, what am I writing first? What's my first base? Yep, and what is that? Because we have them all there. It's nice. 36 plus, what do I need now? I need a 2 parentheses. We're opening it up. What's the next number I should write in there? 75 plus 96 plus 99 plus 80 what? 84 plus 51. Close that doubling parenthesis. And then, even though I don't have to write it, I still want to. On the outside, the last base is 0. And there we go. You confused? Okay. 1/2. This is the height, the 3 we got right. The first base is this length here, which is the y coordinate of the -8, which is 36. Okay. Now we have to double all the internal bases. So 2 times this length, which is 75. You see it? Oh, yeah. And when you do this, you get You get an answer? 1,269? Woo! Do you guys understand? What? Now, that's square units, whatever this is. You know, guys, when you find area, you're finding how many of these little squares you can fit in this two-dimensional space. I think a lot of people still, so 1,200 and whatever, 69. Yeah, that was pretty good. Yeah, that's what I got last time, I think. Let's see. I'm checking. I just trust you. It's good. Yeah, we're not doing that one. Okay. Now, sometimes, just like with the rectangles, you're just given a table, which is even easier, right? Now, the big question when you're given a table is, in this case, are the heights all the same, or do I have to do them all separately? Look at this one. Do you think the heights are the same? Or yeah, what is the height going to be? 2, because the heights are going to, that's just the difference between consecutive x values. And you see it's always 2 for all of them. So we will be able to factor that out. We're trying to get the area under this velocity graph, which represents the distance traveled, by the way. So, what's going to be out front? 1/2. I like that you guys aren't forgetting the half. You know, it's part of the formula. The height, what did we say the height was? Okay. Now, in the parentheses, all the information you need is there. They have to give you all the numbers you need. Sometimes they give you too many, but in this case, perfect. Yeah. The one we just did, 1,269? Well, that's what Jessica said. We have no idea. No. But we get the idea. All right, what goes in the parentheses? We want the sum of the bases. Internal ones are doubled, so what should I write? 6 plus 2 times. Nice. Look at that. And don't you love it when you have a half times 2? That's the best. I think I know what it is. What do you think it is? 80. Now, does anyone know what the units would be? Well, when you find the area under the velocity graph, you have the distance traveled. And velocities measured in meters per second, and time's measured in seconds. Nope, that's acceleration is measuring that. It's just going to be meters. Just think about area, you're just multiplying. Yeah. Don't worry about the units for these. Yeah, we're going to get into that later. But isn't the table easier? It's like, really, they found all the y coordinates for you, which is all you really need. You don't need the graph. Ready? Oh, no. This one, they just gave us a function. Does anyone know what y equals 1 over x looks like? If you do, show me with your hand. Oh, you got it. I think I've seen one. Oh, you got it. Right. Yes, there are 2 parts to it. Nice. All right, you guys are good. Yeah, there are 2 parts. We're only going to worry about the part over here. But, you know, you have the one over here, too. Inverse variation. Now, we want to approximate the area under y equals 1 over x from x equals 1 to 5. Now, don't just mark off those x values willy-nilly, okay? What are the numbers that we need to write down? Well, we definitely need the 1. That's where we're starting. And what else? What is the other one we'll definitely have? 5, right? But before we fill in between the 1 and 5, we better figure out the height of each one of these trapezoids. What is the height going to be? 1. So we kind of lucked out here. So the height is equal to 5 minus 1 over 4, which equals 1. So starting at 1, we could just keep adding 1. So 2, 3, 4. Those are going to be, you could draw your little trapezoids in if you enjoy doing that. Not that you have to. Really does nothing. Ooh. What a good fit those trapezoids are. That is pretty good. All right, I'm going to set up a little table because I enjoy that. I enjoy that. 1, 2, 3, 4, 5. All right, we just need the y coordinates, right? So we just plug them into the function. When x is 1, what's y? How about when x is 2? 1/2. When x is 3? 1/4. Everyone see where we're getting those? Y equals 1 over x. So, all right, that's all we need, right? Are we ready to get our trapezoidal approximation? And it's going to be a good one. What do I need out front? 1/2. And what is the height? Even though I don't need to write it, I still want to write it. 1. Now I need the big parentheses. What do I put in there? 1 plus, I remembered the 2, times 1/2 plus 1/3 plus 1/4, close it, plus 1/5. Riley wants to do it by getting a common denominator and do it the long way. Is that what you're going to say? Oh. Do you have an answer already? Okay, what'd you get? Wait, say it again. Can you tell me what is a fraction to hit math 1? 101 over 60. That's right. Now, like, if you didn't want to do it that way, you could have just got a common denominator for all the fractions and added them and done all, some people enjoy that. Yeah, a different time. But 101 over 60, that's great. I got one more thing I got to show you. With the trapezoids, you probably can almost see it coming, but we'll see. Oh, now another table problem. Why don't you give us one of these? We just did a table problem. Yeah, the height's not the same. What? What do you mean? What goes from 3 to 4? Oh, yeah. So the heights are not the same. So you can't pull out the height, right? What's the only thing you can pull out? The half. So when we do this, okay, we can still pull out the half. But then for each one of the trapezoids, what do we still need? The height times the sum of the bases. So for each one of our trapezoids, we're going to take the height times the sum of the bases. Oh, you want to just pull out the 3 for the first 2? No. Yes, you definitely could do that if you want to. Okay, for the first, what is the height of our first trapezoid? 3. Now I got to multiply that by the sum of its 2 bases. What are the bases for the first trapezoid? 5 and 1, so 5 plus 1. Can we write 6? Nope, you have to write 5 plus 1. No, you don't. But you, when you're reading your notes later, you're like, oh, I don't know what you did. I'm just going to give up and watch Netflix. So, All right, let's move on to the second trapezoid. What's the height of the second trapezoid? 3. Now, tell me the basis for the second trapezoid. 1 plus 2 we're going to write. Well, sorry. All right. And what about the height of the third trapezoid? 4 times, what are we going to write in those parentheses there? 2 plus 4. All right. So we have 1/2 times. Slowly. 27 and 24, 51, 51. No? You didn't get that? Oh, you got that? Cool. Not bad though, right? I just have to ask you one thing. I have to show you the homework questions too. answers. Now, if you have a graph, a function that's concave up, like so, right? And you're trying to use trapezoids to approximate the area under the graph, right? Is this going to lead to an over approximation or under approximation? Over. It's not like something you have to memorize, you just got to be able to visualize it. And likewise, if you have a graph that's concave down and you're trying to use trapezoids to approximate the area, what kind of an approximation is that going to be? Under. Now, I'm going to go back and give you that the homework answers. Sorry, I might have to show you whatever we miss, whatever you don't get tomorrow. I'll see if maybe I can squeeze one in there. Where'd it go? One more? There it is. By the way, the illustration that they gave you for number 4 was wrong. That middle, there were 3 rectangles. The middle one should only have had a height of 1, not 2. So it might have made you write an answer of 12 instead of 10, which is what it should have been if you got that one wrong. Number 4, they gave you the picture with the rectangles. But you see that middle it's supposed to be inscribed. So the rectangle should only go up to the parabola and across. So it should only have a height of 1, not 2. So the total area would be 10, not 12. Which ones will we go over tomorrow? I want you to look at this and tell me which ones you're having trouble with, because I don't believe that. 5, 7, 5, 7, 8. Let me just look at one of those things. I have to. I got to do it. I just want to see if I can do it. Do it. Wait, did you want which one first? 7. Well, you know what? I could do the ones with these things are easier. Oh, it's just like 7, you said? Who said 7 or 8? Either. Okay. This one is left-hand Riemann sum. These widths are all different, so you just do them separately, right? So what's the width of the first rectangle? 4. Which y are we going to use for the height? The 0, right? So 4 times 0 plus, for the next rectangle, 1 and times 1. 1 times 1 plus 1 times 2. 2 times 3. You just had to decide for each rectangle which y to use. And then you could see it down here. And then so you get 0 plus 1 plus 2 plus 6, which is 9. Yeah, you know what? I actually think I might have like another minute or 2. So what was the other one? 5? Oh, no, it's all right. But just remind me tomorrow, because tomorrow we're going to review this. We're going to do like a practice quiz together, and then on Friday you're having a quiz on all this. I love sad stories. Yeah, let me just break her.